Hello and welcome to Otten Math. In this edition of Otten Math, we're going to handle some practice problems involved in factoring and solving quadratics when the value in front of the quadratic is going to be greater, the absolute value is going to be greater than 1. Okay, first problem. Let's erase this here, at least this part. So the first problem is going to ask us to find the sum of the roots of the equation. So we want to find the roots of the equation, then add those two together. Okay, so we have 3x squared plus 10x minus 8. So if we recall from factoring quadratics when a is going to be equal to 1, the first step is going to be to find common factors. Second step is to look for special product patterns. So we see that there are no common factors in 3, 10, and negative 8. And just on the surface, it doesn't appear to be any special product patterns in this quadratic. So what we want to do now is, and again, recalling from the lesson, we want to place the product of a times c in the top of the box, or top of the diamond, and the value of b for bottom, at the bottom of the diamond. So I have negative 24 at the top, or 3 times negative 8, and then I have 10 at the bottom. And next step is to list the factors of negative 24 that add to 10. So I have 1 and 24, 2 and 12. Okay, 2 and 12 look like they're going to work. In fact, negative 2 and 12 will work. So what I do next is I create my box, and in my box in the upper left-hand corner, I'm going to put the first term, so 3x squared. In the bottom right-hand corner, I'm going to put the c value, the third term. And then I'm going to put the factors negative 2 with the variable and 12x in the bottom left and upper right. Then I'm going to take the common factor from the first column, which is going to be x, the common factor from the second column, which is going to be 4. And then I'm going to look at the first row and take the common factor of the first row, which is going to be 3x, and the common factor of the second row, which is going to be negative 2. And so I've factored my quadratic as 3x minus 2 times x plus 4. And I can see that the roots of the equation are going to be 2/3 and negative 4. When I add those two together, I have negative 3 and 1/3. In my second problem, I have 9x squared plus 12x plus 4. And so again, the first thing I look is for common factors. 9, 12, and 4, I do not see any common factors. It might be I have a perfect square here and a perfect square at the end. It looks potentially like I have a perfect square trinomial, but let's factor it first and see what we get. So again, a times c goes in the top. 9 times 4 is 36. The b value goes in the bottom. I'm looking for the factors of 36 that add to 12. So I have 1 and 36, 2 and 18, 3 and 12. I have 4 and 9. And I have 6 and 6. So 6 and 6 look like they're my special, or my factors. So I'm going to add the variable here and place those two values in the bottom left and upper right. I'm going to take the common factor from the row, and I have, for the column, it's 3x. Common factor from this second column is plus 2. Common factor from this row is going to be 3x again, and common factor again plus 2. So indeed, I do have a perfect square trinomial x plus 2 squared. So my root of this equation is going to be negative 2/3. In this case, the mathematicians would say there are two roots, negative 2/3 twice, but in this case I just want you to answer, there's no sum of two values, just one value. Your answer would be negative 2/3. Okay, moving on to number 3. I have 4x squared minus 8x plus 3. I don't see any factors here, common factors. It doesn't look like any special product patterns. 4 is a perfect square, but 3 is not. I take the value of a times c, so 4 times 3 is 12. B value, negative 8, goes in the bottom. I'm looking for factors now of 12 that add to negative 8. I have 1 and 12, 2 and 6. Okay, so it looks like some value of 2 and 6, let's say negative 2 and 6, add to negative 8. Negative 2 and negative 6 add to negative 8. I add them in the bottom left and upper right. And I do the same process that I did before. Common factors of 4x squared and negative 2x would be 2x common factors of negative 6x and 3 are going to be 3. Common factors of 4x squared and negative 6x are going to be 2x here. And negative 2x and 3 would be positive 1. All right, so I end up with my factored quadratic is 2x plus 3 times 2x plus 1. So this is one of those cases where we have an exception. And the exception is that if we take a look at the quadratic, we're trying to find a value that sums to negative 8. But I have two positive values here. So I figure out that this is not going to work. And when I do the factoring, I'm going to need to go back and change these values to 2x minus 3 and 2x minus 1. So my factors, so these are just one of the special cases. And again, you're going to have to go back and take a look as you check your work. My values, or my roots, are going to be 3/2 and 1/2. And if I add those two together, 3/2 plus 1/2, I get 4/2 or 2. Okay, last problem. Number 4, this is a word problem. I'm creating a deck around a pool that has a uniform width. The dimensions of the pool are 15 by 20 feet. After finishing the deck, the total surface area of the deck and the pool is equal to 414 square feet. Okay, so if I have a uniform surface area, I'm going to identify that uniform width is going to be x. So I can see that if I want to figure out the dimensions of the pool and the area of the pool, it's going to be 20 plus 2x times 15 plus 2x is equal to 414 square feet. So 20, the length of the pool, plus 2 times the uniform width, times 15 times 2 times uniform width. And again, the area of a rectangle is length times width. So I have my length here times my width here equals the area of 414 square feet. So I'm going to use my FOIL method to express this and then to solve for x. So I have 20 times 15, or 300. That's the first. Outside is going to be 20 times 2x, which is 40x. Inside is going to be 2x times 15, which is 30x. And then 2x times 2x is going to be 4x squared, is equal to 414. Now don't forget this. I did it in when I did this video previously, and I had to restart from the beginning. So here I am again, making sure that I have my area here. So this simplifies to 4x squared plus 70x plus 300 minus 414 is equal to 0. Or I can rewrite this. Let me just erase this part and say minus 114 minus 114 is equal to 0. Now I want to factor this quadratic. First thing I do is I look for common factors, and in fact the common factor would be 2. So I take that 2 value out of the original quadratic and use the distributive property to place it outside the parentheses. Now I have 2x squared plus 30x minus 57. Okay, now I'm going to create my diamond in box. 2x squared plus 35x minus 57. Okay, so I'm going to create another sheet here. 2x squared plus 35x minus 57. 2x squared plus 35x minus 57. Let's just go back and double check that. 2x squared plus 35x minus 57. Okay, so I create my diamond. And the top I have 2 times negative 57, which is going to be negative 114. And the bottom, my b value, is going to be 35. Now I have to look for factors of negative 114 that add to 35. So quickly I wrote down a couple while you were waiting for me. 1 and 114, 2 and 57, 3 and 38. So I have factors of 3 and 38 that add to 35. So in this case, negative 3 and 38 would be 2 factors that produce negative 114, but sum and also sum to 35. So I have negative 3 here and 38 on the right-hand side. I create my box, or something that looks like a box. I put my first term of the quadratic in the upper left, 2x squared. Negative 57 are my c value in the bottom right. I have negative 3x here and 38x in the upper right-hand corner. Now I'm looking for the common factors. Common factors in the first column are going to be x. Common factor in the second column is going to be 19, so 19, 38, 57. I don't expect you to do this quickly at home. Common factor in the first row is going to be 2x, and common factor in the second row is going to be negative 3. So I have x plus 19 times 2x minus 3, and I find out that my roots are negative 19 and 3/2, and plus 3/2. Okay, so it looks like the only value that's going to work, I can't have a negative value for the width, so negative 19 is not going to work. So plus 3/2 is my only value that will work. So going back to the original question, find the width of the deck. The width of the deck is going to be 1.5 feet, or we could also say that the width would be 15. The uniform width is 1.5, but the actual width is going to be 15 plus 1.5 plus 1.5, which would be plus 3, or equal to 18. So the deck and the dimensions of the deck after we put the uniform width around would be 18 by 23.